Okay, we ready?
Yep.
Okay, we're boiling water here. I don't know if that's hot enough yet for what we're doing, so we may take us a little bit longer. But we're going to start off and take what's known as a Stirling Engine, put it on top, and I don't know if there's enough heat there. Stirling Engine can work off of both hot and cold. And we'll see if... I'm going to have to overcome friction at some point. Let's see if it's trying to push. Almost. Just a little bit more time. There you go. Now, just like in all instances that we have a heat engine, you must have a hot reservoir and a cold reservoir. Now, this up here, all being made out of metal, this right here allows for cooling of the gas once it's gone through the piston. And I'll lift this up so you can see. Can you see that piston down there moving up and down? Okay. And again, it's just working off the steam coming off of this. If by the way, if I had a cold reservoir and this were warm enough up here, you could do the exact same thing. It would just run backwards. Okay, so we'll remove that Stirling Engine and do one more here. While we've got that, we've got sufficient enough hot water, I should imagine. Turn that off, out of the way. And now we have a hot reservoir and a cold reservoir in what's known as a thermocoupler. I'm not sure which one we used yesterday, so hopefully this one works just as well. We'll put that in. And again, we have a difference of temperature. It's not about temperature, it's about difference of temperature. And fortunately, with water, it's easy enough for us to use very cold water, you know, with ice and boiling water. We'll give it a little bit of time for what's actually happening is it's moving electrons due to this change in temperature, and that actually runs a little electric motor. It's more complicated than that, but that's all we need for this. And I just kicked it over so that there's a little less, because the friction holds it on a little bit. Now, in all of these cases, what you should know is there has to be a hot reservoir and there has to be a cold reservoir. There has to be a difference in temperature. It's not about temperature, it's about difference in temperature. Just as if you go to the top of Mount Everest, you can't roll even though you'd be at very high altitude, if it was flat, you could not, nothing could move if it was flat. A ball couldn't move if it was flat, but if there's a slight elevation difference, it would move. It doesn't matter the elevation, it only matters the difference in elevation. Okay, stop. All right, we already showed this thermocoupler here. Now notice the direction it's moving, and I'm going to pull this out and let it stop so that you see which way it's moving. And we'll let it cool down on its own. Don't need to advertise that. Okay, and the reason it's still moving is that this side of the metal is still cold and that metal over there is still hot, so it takes a while for it to get back to room temperature. Once it's done that, we'll be able to see it. You can see that it's moving counterclockwise right now. And then actually let's do this. Let's go around and we're going to put it in the opposite direction. Give it a little bit of time. Okay, here it goes. Now it was going counterclockwise beforehand. Oh, there it goes. It's getting ready to go. And notice which way it's trying to move. Clockwise. Oh, almost. There you go. Trying to get a little bit of help there, huh? Yeah, we overcame static friction. There it goes. So it's about whichever side is hot and whichever side is cold. There we go.